Hello, everybody. Hey, good afternoon, and welcome to this session. So the scope of my session here is to frighten you so much that on Monday, you'll go back to your job and plan to update to JDK 11. So my name is Simone. I work for the company that is behind the Jetty open source project. So I'm one of the Jetty guys. But today I'm going to talk about just JDK, not Jetty. Well, a little bit of Jetty, but very little. So what's going on with JDK 11? It has been released almost a month ago now, and it's currently has been defined as to be the long-term support release for Java. The previous release that was marked as long-term support release was JDK 8. But I don't know if you know, by now JDK 8 is going to be maintained until January, and then after January, things are going to change. And especially the interesting thing is that Java 9 and Java 10 are already unmaintained. They are abandoned. Their repositories, the open source repository for the source code has been marked as read-only. There's nothing, no code, no changes that is going to be backported to Java 9 and Java 10. So basically, your only option is JDK 8 now. You can still be in JDK 8 until January, but then from there on, it's like JDK 11 and 12 and 13 and 14. How does it work? So what is the new thing about JDK 11? So there's the open source repository, which is OpenJDK 11 repository, okay? And from this source code repository, a number of vendors derive binary builds. One of the vendors is, of course, Oracle, and it derives an Oracle JDK based on the OpenJDK source code. Oracle does another thing, not only builds an Oracle JDK that you can download from java.oracle.com like it always has been, okay? And probably most of us have downloaded the Oracle JDK in the past and used the Oracle JDK and not directly OpenJDK binary builds, but Oracle JDK. So Oracle, during the life of a JDK, 6 months, also builds OpenJDK binaries. These are downloadable from a different place, which is openjdk.java.net. Okay? So there are two different builds of basically the same thing, and you can guess that the difference between these two is only the licensing, and we will go into the licensing in a second. However, Oracle is not the only player and not the only vendor. There are other vendors and other parties that are actually building OpenJDK. One of them is a project, it's a community project started by the London Java user group called Adopt OpenJDK. They also check out the source code, they build a binary version, you can go to adoptopenjdk.net, and there you can choose the platform, you can choose the version, and you can download a binary version of OpenJDK. And of course, there is Red Hat. Red Hat is currently working on a new garbage collector called Shenandoah. So what do? They basically check out the official repository source code, they add Shenandoah code to their JDK, and then they build a Red Hat JDK binary, okay? And Azul system is doing something very similar to the OpenJDK build and the Adopt OpenJDK build. They go check out the source code and they build something called Azul JDK binary called Zulu. And so on. So you can do it yourself. It's like in your company, if you don't like to wait for vendors or whatever, you can just go to the source code, download it, build locally your JDK, and off you go. What is the problem with the licensing? So what is that has changed in JDK 11 with the licensing? Well, the OpenJDK binary built by Oracle, OpenJDK binaries, are GPL licensed with the class path exception and stuff. Adopt OpenJDK is going to be GPL, Azul Zulu is going to be GPL, okay? But the Oracle JDK binary is now released under an Oracle license that is different from the license that you used to accept when you downloaded JDK 8, 9, and 10. In 11, the license has changed and now requires you to pay if you use the Oracle JDK in production. All right? So you need to pay Oracle to use JDK 11 in production if you use the Oracle JDK that you download from the Oracle website. If you download from java.net, then that's GPL licensed, and then you can use it for free in production, all right? So, and this is all true for the 6 months now that is the life of a current major JDK release, right? So the question is, all right, so we are in those 6 months, but what happens in March, okay, when JDK 8 will be now out of life in a way, because it ends in January? What happens in March? Well, this is what happened in March. You have two choices. Either you upgrade to Java 12, and again, you download the JDK for Java 12 and blah, 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 or you stay on Java 11. But how do you stay on Java 11? Well, after 6 months, you have these other choices. You have downloaded a JDK version, so the current one is 11.01, okay? Well, you never update. You just have 11.01, you stay on 11.01. What is the downside of this is that you may open yourself to security vulnerability or to bugs or to things that don't work properly, and that, you know, that's a problem. If someone exploits your Java installation on the server and then, you know, steals something from you, you know, user data, money, whatever, then the blame is on you because you didn't update the JDK and then those people exploited the vulnerability. The other choice that you have is, of course, that you have to update the JDK. How does that work, though? Because Oracle, if it finds a security vulnerability, will update JDK 12 or 13, 14, 15, and so forth, but it will not backport that fix to the JDK 11 repository. So who's doing that work? Well, it turns out that this work has been basically taken over by the community, which in this particular case means basically Red Hat. Red Hat has devoted a number of engineers to basically do this job for the community. Note that what I'm telling you now has never happened ever yet, okay? Because we're not past those 6 months yet, and this is all new. There's a new security group called OpenJDK Vulnerability. When a new vulnerability is found, there is this group which is open, which Red Hat participates and Oracle participates and vendors participate, where the vulnerability is discussed, a fix is discussed, and then eventually promoted to a fix and then applied to the source code repositories, okay? So there is a community collaboration around OpenJDK. You're not alone, you're not, you know, in the hands of a nasty vendor or something, but you have to understand that, you know, this is all new. We'll figure out as time goes by how this exactly works, and especially the timing, okay? A vulnerability is found, how much time does it take from the vulnerability found to a new version of the JDK? And so once Red Hat backports the fixes to the OpenJDK 11 source code repository, they may tag a release tag, and then you have to, you know, someone has to create binary builds. Adopt OpenJDK will build the new version with the fix and release it under the GPL license, as they do right now for everything. But the other vendors are very likely, especially Oracle and others, are very likely ask you to pay for support. So basically you have to have a contract in place with Oracle or with Red Hat or with Azure Systems and so forth, so that they will provide a service to you. They will tell you, hey, we just built a new version of JDK 11. You are a customer on JDK 11, even if it's, you know, the current JDK is maybe 14, but you're still on 11. And there's a new version of 11, and so Azure System will just call you and say, hey, there's a new version, so please update because we fixed a bunch of security vulnerabilities, so upgrade. But of course, you pay for this service, all right? So this is the current status of things. If we if I manage to save a little bit of time at the end of the presentation, I'll get questions. Otherwise, you can find me around and ask questions if you like. So now let's dive into the most important features of Java 9, 10, and 11. So who's in Java 9, 10, or 11 already in the audience? 2, 3, 5. Okay. So very few. So let's go through the main changes. There's a lot of changes. Like each one of these could take like 2 presentations. Just the changes for Java 9 could be 2 sessions. Just the changes for 10 could be maybe 1 other session. So I'll go a little bit fast. The idea here is just to give you hints of what has changed, and that possibly will, drive you to your boss on Monday and say, hey, we have so much good stuff on JDK 11 that it's really worth for us to plan to change. So the biggest change that was introduced in Java 9 was, of course, the Java module system. And that was really cool. But along with it, there were a number of breaking changes. So things that changed at runtime, so your code compiles still fine, but the runtime system is different. It doesn't work as before. So what you need to do is basically you need to plan, and you need to do a very careful testing of all your applications, because they may not behave in the same way when you run them in JDK 9, 10, or 11. In particular, for example, they removed a bunch of stuff. I don't know if we used these things, but tools.jar that was previously used to do, for example, attaching to a JVM or compiling Java source code, or using the doclet for Java docs was removed. Well, it's still there in a way, but it's not referenceable anymore as tools.jar. Okay, so if your application was doing that, now will not find that file, which was there since 20 years, since the beginning of Java, right? They removed JavaDB. I don't know if you used it, and they removed the endorsed and extension directory mechanism. Who was using that, just out of curiosity? Couple of 3 people. Okay, so that's gone. There's no replacement for that. And so if you were using it, start to plan doing something different. But then we go to the runtime changes. So the first thing is that the module system required changes in the way class loader were implemented. In particular, it was always true, again, 20 years of code and 20 years were always used to the same thing, that if you were accessing the system class loader, well, that class loader happened to be a URL class loader, and you could cast it down to a URL class loader. And then when you do that, you can now access a new method, which is only particular of URL class loader, called getURLs. And then at that point, you can see all the jars that made part of that class loader class path. Well, now this throws a class cast exception. Like we in Jetty were doing this in order to find what was the class loader, in order to look up the jars, because as a server container, we need to scan the classes in jars in the class path. And so now we can't do this anymore because it throws an exception, Java 9 and plus. So it's a runtime change behavior that doesn't work anymore. Loading resources is also changed. So if you do, how many of you did this? Class loader, get resource, and then you were passing in a class, or maybe even more commonly, a properties file. How many of you? Yeah, almost everybody. So if you follow the implementation of this, class loader, get resource, etc., delegates to the parent, eventually calls a method, the method in JDK 9 has a very simple implementation. It says, return null. So what do you get before? Before you were actually getting a URL, but now you don't get a URL anymore. You get a null back, and you get a null pointer exception the next line of code. So what you need to do here is not using the class loader anymore to load the resources, but you need to use classes. Class, JavaLang class, has a similar method called getResource that returns a URL. Why you need to use a class? Because if you use a class loader, you have no idea what module you are accessing. But if you're using a class, well, the runtime system now knows, oh, this class belongs to this module. has the module given permission to access internal resources? There's new checks at runtime made by the module system that allows you to either return or not return resources depending on how you have configured your module. Can module A access resources in module B? That check is now embedded in the source code, in the runtime, and it wasn't there before. So the behavior has changed. Well, this is nice. So the string for Java version has changed. So this broke basically almost all Maven plugins and broke Jetty too. We had, we were just doing something simple, system get property java.version. And then we were parsing it and say, okay, discard the first number, 1 dot, because, it was 1.1, 1.2, 1.8, etc. Except that in Java 9, the 1 at the beginning was not there anymore. Well, Java 9 introduced a parsing class called Java Lang Runtime Version, but this class is not able to parse the JDK8 version of the string. So if you are like us, you need to work on both JDK8 and JDK9, you need to write your own parser for this class. And this took a while to be fixed. Like, we couldn't even start the build of Jetty because the Maven plugins that were doing this were broken. So, we start the build and then boom, explodes. The build explodes because it doesn't work anymore. Oh, we don't support this version of Java. And say, what? All right, again, a runtime change. API have been encapsulated, so you cannot access any more sun.star classes or com.sun.star classes. They have told this, Oracle and Sun before that, they have told this for 20 years, but we never did it. That's okay, we access these classes, that's fine. Who's gonna ever change this? Well, they did. Now you cannot access them at all. Unless you do some crazy command line things. And, fortunately, the functionality that were exposed by these classes were now in public APIs. But of course, you have to upgrade. You have to use new API available in JDK9 and stuff. And we're going to see a few of them as well. For example, finalization has been deprecated, and now there was a mechanism called SunMist Cleaner. Now it's a public API called the Java Lang Ref Cleaner. Unsafe, some of the functionality of unsafe are now available in a new API called the VarHandle, which we're going to see in a second. All right, so that's all cool. One thing that they added in Java 9 was the capability for a class to be completely replaced at runtime. So for example, imagine that you have this a.class. Okay, you're using JDK8 API in that class, but they are ugly, they are maybe very slow, and in JDK9 there's a new functionality, new API that are very easy to use, and you can use them and they're faster, they're better. But how do you do that? Well, you can put a new class implemented with JDK9 APIs under metainf version 9. And then when the class loading mechanism has to load class A, it knows the runtime is running in, and therefore it says, well, if I am in runtime 9 or greater, then I'm going to look for this class under metainf version and load this class instead. Okay, so you have one behavior in JDK9 or one new API usage of new APIs in JDK9, and if you're running the same jar in JDK8, then this class is going to be loaded because the JDK8 doesn't know that it has to look inside this directory, all right? That may be handy. It's quite complicated to create a jar in this way. For example, using Maven or tools, it's a bit complicated. You have to take one class, generate compile it with Java 9, put it aside, compile the other class with Java 8, and then you have to put it in the right places. It's a bit of work, but not impossible. Okay, so VarHandles is the other nice functionality. For example, what problem are they solving? Well, if you write data structure that needs to be very efficient and concurrent especially, then how do you naively implement a concurrent link queue? Well, it's a queue, so you have a class node which contains the value and then points to the next node with the next value. Okay, it's a queue, so it's a bunch of nodes that points to each other and it's linked. But then how do you access the head, for example, for removing an entry? Well, you can do it this, you need to access the head atomically. And of course, in order to do that, you have to use an atomic reference, because the API for you to manage concurrency are inside atomic reference. They're not inside node, and you cannot put them inside node. It's like it's going to be complicated, more complicated. So, but in this way, you have a number of jumps to reference and eventually arrive at the element, right? You have to dereference the concurrent link queue reference. Then you have to go to the field head. Then you have to go inside the atomic reference. In there, there's another pointer that points to class node. In there, there's another pointer that points eventually to your value. Okay, so it's a triple jump in order to get the value. So that was not really efficient, and so they introduced VarHandles. So now you don't write any more atomic references. What you do is this. You define your field as a normal node, but then you still want to be able to do concurrent stuff on this guy, right? So what you do is that you can use a VarHandle, and you tell VarHandle basically do some reflection magic on this field and give me back a VarHandle. Once you have a VarHandle that it's linked to this particular field via this lookup API, then VarHandle will give you the atomic API. And so at that point, you're basically, because the JVM VarHandle knows about all this, it's all implemented by the JVM, you have basically removed one of the jumps that you need to do, okay? Because you don't go anymore through the atomic reference, you can directly access the field using the VarHandle API, okay? So VarHandle basically seems like another jump that is just replacing atomic reference, but it's not. It's actually known by the Java virtual machine and allows you to access directly this particular field, augmenting the capability that you have on that field with atomic APIs. So it's a nice improvement for low-level data structures. They introduce a new process API using the builder pattern. So you can see now it's way easier to start external processes from Java. You can do command, directory where you run the command, redirect the output, or maybe discard it, and you just start the process. And then you can get a handle of this process. You can even access the PID. Woohoo! Finally, we can get the PID of a process in Java. And you can, on exit, returns you back a completable future onto which you can attach a callback and say, okay, call me when the process has exited. All right? So it's a simple, nicer API. If you use external processes, go to JDK9 because the API for launching them is so much better. Of course, with that, they made improvement in Java util concurrent. In particular, they introduced a class flow, which is basically reactive streams, okay? And the same exact API, same exact semantic, but now it's embedded in the JDK, and it's a good thing, and it's probably going to be used in newer API. We'll see that this is actually being used in JDK 11. Completable future got timeouts. So now you can complete a completable future after a timeout, or you can just throw an exception. So again, API are better. One thing that really surprised me, also in JDK 9, was jshell. It's actually a read, eval, print, loop, REPL interface, like many scripting languages have, but it's pretty powerful. For example, it has auto-completion. You can auto-complete imports. It has Javadocs. It prints there's a key combination on the keyboard that prints you out the Javadocs for that particular method you're on. Has a history. You can search things inside. And it has a nice functionality of syncing with an external editor. So you can load a file that you're editing, okay, in an external editor. You do changes in there. You save. And when you save, the jshell terminal is aware of the changes that you have done. And when you do changes in the terminal, these changes go back into the external editor. So the two are actually double synced. So it's really nice. It's really useful if you want to, do something very quick on Java, for example. Oh, I don't remember, what is the syntax of this method or whatever. Or maybe you're teaching someone to do Java and you want to do something quick and dirty without opening up the IDE, creating a new project, blah, blah, blah. You fire up jshell and it's really powerful. G1 has been promoted to be the default garbage collector. It has been much improved everywhere, but we'll see that JDK11 is going to introduce other 2 collectors even, not only 1. And so, G1 is improving. It's on the steady path to improving. So if you're still using G1, you're great. One thing, though, that I would like to mention after all these changes is this. Think about your application, okay? And you say, okay, I'm going to move to Java 9 from JDK 8. Okay, now you need to take care about class loader changes that maybe you have changed, okay? And so you scan your code and maybe you're good. Do you look up system get property for java.version? Well, maybe you don't, and then you're fine too. Are you using some command line options on the garbage collector? Well, maybe you don't, and then you're fine. But all this, remember, it's not only something that you have to do in your code. You have to basically scan recursively all the libraries that you are using, because maybe you are not casting down to a URL class loader, but a library that you are using is doing that. So is that library ready for JDK 9? Well, you don't know. I mean, you have to definitely go on the latest versions of every library, every dependency that you have. But imagine that library is using another library as is dependency, okay? And then recursively you have to go down and ask, okay, are you doing something like a class loader get resource? Well, maybe they are doing that because they have configuration files where they configure the library, and now they're going to get null pointer exception out of it. And so your code is going to blow a runtime. Imagine if this is actually hidden inside an if statement that says, if very rare condition apply, then cast down to a URL class loader or do class get resource. Have you written a test case for that rare case? Maybe you haven't. But it's not only you. It's like, has the library that you are depending on written a test case for that particular rare case? Is the library depends on recursively? Have they, taken care of all these changes that happen in JDK 9 and 10 and 11? If they haven't, then you're kind of in trouble. It's like, well, you don't know if at runtime your application is going to work. So my take is that very differently from before, it is not enough for you to just download JDK 11, just, put it there, deploy your application on JDK 11, and boom, it works like it used to be. It's not anymore like that. It's a complex activity that you need to plan. And it may take time to do it. Like we as a Jetty project were the first adopter of JDK 9 and so forth. It took us like 6 months to only be able to build Jetty with JDK 9. Why is that? Because we went there and one plugin, Maven plugin, was broken. So we filed an issue to the Maven plugin. And then another Maven plugin was broken when the first one was actually fixed. And then another one, and then another one. And then we discovered the get resource thing. And then go fix the Jetty code. And then turns out that the get resource thing was also used by a Maven plugin. And so file another bug and fix that too. And so the process is, taking time. So plan for it. Another thing that was changed in JDK 9 was GC logging. Who's adding GC options on the command line here? Oh, very few. All right, so for those that you do, the command line options are completely changed now. So the same command line that you were using in JDK 8 doesn't work anymore in JDK 9, but there's more to that. In JDK 9, they removed more than 50 options from the command line. And if you have one of those specified on the command line, well, the JVM doesn't even start. So go tell your DevOps, and not only your just developers in the code, and say, hey, we are updating to JDK 9. Not only you have to take care about the code, you have to tell the people that launch scripts or do things with the Java command line, hey, go there and double check, or maybe write 2 different scripts, one for JDK8 and one for JDK9 plus, because now the command line is completely changed, and you have to test it, and verify that actually the JVM starts as you think it is, because maybe it's not. It's not. So yeah, another thing that has changed, and so double check again. So that's about it for JDK9. There's a lot more, but I haven't even spoke a little bit about the Java module system, but it's for another day. So Java 10 finally. So most prominent feature of Java 10 is var. And this is like a weird feature in my opinion, so much that they had to put out this document which details exactly when is it that you can use var and when is it that you shouldn't using var. Why the feature is a little bit weird? Well, because removes the type from the variable, and so what you get is basically this: var list equal new array list is now list is actually an array list, like the concrete class. Of course, cannot be anything else, because how can the compilers decide whether this should be of type list, of collection, or even object? Right? I don't know. So, these examples are pretty straightforward, even to read, and so that's nice, but there's some, the important thing is that if you've ever written code like this one, int var equal 13, that will still work, because they made var is not a keyword, but it's actually a reserved type name. So wherever you need a type, the compiler is gonna, ask the question, say, okay, is var allowed here? But if it's an identifier, like in this place, the compiler says, okay, I take any identifier, var is not an identifier, it's a valid identifier, so we're good. So good var usage is this one. What type is message here? String, right? That's evident. All right, so this one is another nice feature. Var anon equal anonymous inner class of object with a count variable in it. With var, you can actually refer to this count variable, and which you couldn't do it before, because before, how would you do it? You do object anon equal new object, but of course then anon is of type object, which doesn't have a field called count, so that would not compile before, but now it does. So, maybe for testing or small experiments, this is useful. But processor run, well, what does it return? Now you are kind of in a trouble, because it's like you have no idea. It's like the only way for you to figure that out is to go to the Java doc and, and look at the Java doc. And it's like, okay, I need to do, so, well, before I could just read the source code. Now it's like, well, I have a bunch of variables which I have no idea which types they are, on which I call methods, which seems to work, but it's all a little bit fuzzy, right? And the IDE cannot help you. Like if you do var list equal new control space, new object, it's weird. But whatever, it's in JDK10, so it's there, and it will remain there. So read the document that I linked at the beginning, because that explains how best to use var, but use it with care. It's like, think about using it. So we have also in JDK10 the experimental Graal JIT, which Chris had a session about this morning, which is really cool. So I have modified my slides because it was said that it was not yet recommended in production, really, but then I spoke to Chris and he said, well, Twitter uses it in production, so if they use it in production, then maybe I can too, right? Of course, use case may be different, so your mileage may vary, but give it a go. It's probably stable enough to be used in production. Finally, JDK10 is Docker aware. So if you have a machine that has 48 cores, and then you allocate a Docker container, and then you tell the Docker container you only have one CPU, well, before JDK10, the Java process inside the Docker container would see 48 core, but now in JDK10 it will just see 1 by default. By default, this is all enabled by default, and you can customize it with these additional system properties, command line properties here. But you know, inside Docker, Java will behave properly, like you would expect. And finally, we are on JDK 11, new features. So, 2 new garbage collector, as I was saying before. One is called Epsilon GC, and the second one is called ZGC. Epsilon GC is a no operation garbage collector. What does it mean? It means that it doesn't do any garbage collection. Basically, allocates the heap, allows you to allocate things, fills the heap until it fills completely the heap, and then throws out of memory exception. And that's it. Right? It doesn't do anything. At that point, it doesn't have a full GC even, right? So at that point, your only option is to kill the JVM and restart it, okay? What is why was this added? Because, you know, at one point it says, why? Well, for a bunch of reasons, but one of them is to be a comparison with other garbage collector, okay? Because this garbage collector doesn't have to do all the garbage collector machinery, for example, write barriers, read barriers, you know, maintaining additional data structures and everything, which cost CPU cycles and time to the runtime. So probably the throughput of this collector, it is better than any other collector because there's no, you know, things that needs to be done. And the second thing is that there are actually use cases where you start your JVM 9 in the morning and you operate your service until 6 o'clock in the evening, and then for the whole night, your service is not available. And at that point, you have a big machine and you say, okay, you know what? I measured it, and during those 9 hours of operation, my application allocates 4 gigabytes of RAM, all right? Well, great. I buy a machine that has 16 gigabytes of RAM. I start with Epsilon GC. I give it Epsilon GC 16 gigabytes of RAM, let the JVM run for 9 hours. I know I will never go into out of memory, and I have the best throughput possible, right? So there are use cases that this can be used. The other one, which is what I'm really more excited about, is called ZGC. So this has been actually a project that was coded in the past 5 years in closed source inside Oracle. And it's basically a copy of the same algorithms and the same ideas that are behind Azul Zing, which at this time is probably the best garbage collector commercially available in the Java space, okay? So much so that the company behind Azul, the company, doesn't even promote their JVM with the garbage collector as a prominent feature, because they said, oh, we did this in the past. We have solved the garbage collection problem. Our collector doesn't pose for more than 1 millisecond, or at most, it's in the microsecond range now. It has a very good throughput, the JVM. So, JVM, garbage collector, not a problem anymore. We just give whatever heap you want, and the garbage collector is solved problem, all right? So because that's already implemented, and we have a proof that the algorithm is very good, because we have a commercial product that already uses the same algorithm, and therefore, we know it's really good. So ZGC basically implements exactly the same ideas, and it's now in OpenJDK. And therefore, this collector has a lot of potential. It is not fine-tuned like the Zing collector is, for example, because Zing is much older, it's 15 years of engineering on top of it. ZGC is only 5, but this collector has a lot of potential to become probably the best collector that Hotspot has ever had. So, it is, of course, has trade-offs as well. It trades a little bit of throughput, so it's a slightly slower garbage collector for really low poses. For example, we run our own websites using JDK 11 and ZGC right now, And before I was using JDK10 and G1, and I can tell you that I think the longest pause that I've ever seen with ZGC was probably 1.2 millisecond. And before, I was in the hundreds of millisecond range with G1. And so, you know, it's still experimental and everything, but it is 5 years in the development, and it's, you know, I would suggest you to give it a go, exactly like you want to give it a go to Growl. Finally, in Java 11, they started removing things like methods like thread stop throwable. It's gone. It was deprecated for 20 years probably, and it's now gone. A bunch of other methods were removed. But the most important thing is this. They removed a bunch of modules, and with those, a bunch of classes. So for example, we had the Java Activation Framework completely removed. Java Corba completely removed. Who was using Corba here? One guy, it's gone, sorry. Well, it's gone from the JDK, right? But at this link, you can find the replacement. All these classes are now available as external jars. So if you use those technology, you can still use them. But of course, they have been factored out, put into Maven Central. But the question is, who's maintaining them? Who's improving them? Who's fixing bugs on them, right? So that's left to the community, which means whoever has the goodwill to maintain these things, which may be nobody. So, it's stuff that, it's complicated. But the most thing that I'm most excited of is this removal here. They removed SOAP from the JDK. Yoo-hoo! After, applauses from the back of the audience. Thank you. It's finally out of the JDK, and with it, you cannot believe it, I think 5 or 6 tools related to SOAP and, generating the WSDL for SOAP endpoints, compiling from IDL to Java classes and stuff like that, all gone. It's not anymore in JDK 11. As I said, it's all elsewhere, so it's not gone forever. It's elsewhere, but it's a technology that you really have to ask yourself, do I still need to use it? Like, who's using SOAP here? Holy, half the audience? Oh, wow. Okay, so Monday, you go back to your job and you start really planning the move to JDK 11, all right? Because you really need to. Because, your alternative is to basically pay a vendor, okay? So, which is perfectly fine. I mean, you can pay vendors, that's not a crime. But if you don't want to pay a vendor, then, you gotta be quick and update. Flight Recorder is now embedded, has been donated to OpenJDK. So it's a library that registers all the JVM events and dumps them into a file, which can then be opened with Java Mission Control. Java Mission Control is basically a UI based on the Eclipse RCP platform, which can read Java Flight Recorder events. And so think of this as the black boxes that are in airplanes, for example. That's the same thing for the JVM. It records almost everything, and then you can read what happened when you have a failure. So Java Mission Control is actually a separate download. It's also open source, and it's a separate download and doesn't follow the JDK train. So that's the reason why JMC 7 is not JMC 11, because it has a different scheduling and versioning numbers with respect to JDK. It's not really tied to the JDK. With JMC 7, you can, for example, connect to JDK 10, to JDK 9, to JDK 8, and it will just work. It's a UI application that you can use. One more thing in TLS, in Java 11 is TLS 1.3. It's the newer version of the TLS protocol. What is the deal here? And this is, again, very important. It is that the TLS protocol is very different from TLS 1.3. TLS 1.3 is very different from TLS 1.2, okay? So, for example, in Jetty, we had to go and change our code to actually accommodate the changes that happened in TLS 1.3. So if you're using SSL engine, then you need to do the same thing. And it's like, well, the point is, again, it's not maybe your code that is using SSL engine, but it's a library that you depend on that is using SSL engine, and now you run that into JDK11. Your code is fine, but the library has not been updated to actually take advantage or figure out the changes that happen in TLS 1.3, and therefore you will have random errors at runtime, maybe only in certain cases. So the thing is, you really need to plan these things. And you're going to say, you can do something like, oh, I'm going to take Jetty, I'm going to update to the latest Jetty version, deploy my web application, run everything in JDK 11, and it will just work. No. You got to ask us, hey, do you work with JDK 11? And you have to ask all the libraries that you put in webinflib, are they working in JDK 11? And is my code working in JDK 11, right? So it takes time to do all those checks. Finally, one interesting feature is that you can actually do this. You can launch source code programs. You can do Java and load .java here, not .class. That's nice. Again, it goes towards those that are teaching things. You can actually just write the source code and run it, okay? It will be compiled in memory using Graal, and it's very useful for teaching. And finally, we came around the circle because we can now do JavaScript. The last feature is HTTP client. Well, almost the last feature. HTTP client is now a standard API. The API is based on Java util concurrent flow, so it's a reactive stream kind of API. I would say that it's okay if you want a simple HTTP client. If you want something more complicated, probably this doesn't allow you to configure properly all the things that you really want to. So give it a go. If it fits your needs, great. You don't need to depend on an external library because it's now in the JDK. If it doesn't fit your needs, you're back to using the library that you were using before. So no big deal. The last feature that I want to just mention is something called nestmates. From Java 1.1, we had the ability to write inner classes, okay? However, the JVM didn't know that one class was the inner class of another class. For the JVM, it was just another class, all right? And so when you were able to access from the outer class a private method on the inner class, how would that work? Well, it was a trick done by the compiler. The compiler would generate a bridge method called typically in this way, access $000 and then 001, etc. And then it was calling that bridge method first, and then the bridge method was inside the inner class, and now it can call a private method, okay? So in JDK 11, they changed this, and now they have specified officially what does it mean to be nested in another class, okay? There's a new class file attribute. It's now specified in the JVM specification. There's new reflection APIs like class get nest members. You can ask if a class is a nest member of another class, stuff like that. And of course, the JVM now doesn't have to generate bridge methods because now all the checks are done at runtime, all right? So if you play with bytecode, who's playing with bytecode here? ASM, a few, 3 people? Yeah, well, you need to wait for ASM 7, which has support for, nest members. Conclusions. Upgrade to from Java 8 to Java 11. There's no point in upgrading to Java 9 and Java 10 because they are already abandoned. Okay, so you go straight to Java 11. It will take time. There are a lot of runtime changes. You have to plan for it. It's an activity that you have to plan. And if it takes you more than 6 months, you're going to upgrade into JDK 12, possibly, all right? So you gotta do it. Gotta go on Monday and start working on it. So yeah, go straight to 11. There's a lot of good stuff in JDK 9, 10, and 11 that we just saw. That is, just the good stuff that is in there, it's enough for you to say, hey, okay, this is the long-term support release is going to stay here for at least 3 years. Let's move to JDK11. Let's use the new garbage collector. Let's use Graal. Let's use all the new APIs. Let's use the new performance stuff like VarHandles and everything. It's all good. The JVM has improved a lot because they are using all these things internally as well. So you can take advantage of this as well. So remember, major release of Java now coming every 6 months. So you gotta update and keep the pace, or you have to pay a vendor, okay? Thank you.